Okay, so we're going to take a look at a couple of problems that caused the most trouble when we were doing this in class. So let's look at number 4. It says that segment EH is divided by F and G in the ratio 5 to 3 to 2. So we're going to write that 5 to 3 to 2. And it also tells us that segment EH is 30. So if you recall, what we talked about is being divided in the ratio 5 to 3 to 2 means that their lengths could be 5, 3, and 2, or really any common multiple of 5, 3, and 2. So it could be 10, 6, and 4 if we multiplied all of those by 2. It could be, if we multiplied by 3, 15, 9, and 6. If we multiplied by 10, it could be 50, 30, 20, and so on. Okay, but the goal here is to make EH equal to 30. That's our other criteria. In order for EH to equal 30, that means that these three numbers that we're looking at here, these three numbers, have to add to 30. So you could just actually, by guessing and checking, we found it right here. 15, 9, and 6 all add up to 30. Okay, and we're asked for the length of FG. Well, FG is that middle number, so FG is 9. But we do have a shortcut. So again, because we simply used multiples of our ratio, a common multiple of our ratio, what we can do is set up an equation. And our equation would say that 5x plus 3x plus 2x has to equal 30. I'm running out of room. Okay, so 5x plus 2x plus 3x equals 30. So again, x being that common multiple. We don't know what it is, but we're going to maintain that ratio. We could simplify and see that 10x equals 30. So x is 3. This is that multiple that we're going to use to figure out what each length is. So we'd multiply 5 times 3 to get 15. We'd multiply 3 times 3 to get 9, and 2 times 3 to get 6, which is exactly what we got the first time around. So again, FG is that 3x portion of the line, so 3 times 3 is 9. I'll also take a look at number 5, because that caused some trouble too. So we're given CD as shown, with CA congruent to BD, so let's mark that. And we're told that the whole length of CD is 98. And we know that CB is 3 times x plus 8, and AD is 4 times x plus 3. And the question is, find the length of AB. Okay, so notice that AB is right here, right? And we're given the length of CB, and we're also given the length of AD. So we know that CA and BD are congruent. We can actually make the conclusion that CB and AD must also be congruent, because AB, doesn't matter what the length is, if we add AB to CA and we add it to BD, we've added the same thing to both segments. So we still have congruent segments here. So we can take CB, that expression, 3 times x plus 8, and the expression for AD, and set them equal to each other to find out what x is. So 3x plus 24 equals 4x plus 12. If we subtract 3x from both sides and subtract 12 from both sides, we get that x equals 12. Okay, so x equaling 12 means I could substitute that into either one of these expressions and find out that CB and AD are both 60. Okay, so that means that CB and AD, if CB and AD are 60, that would give us a total length of 120. Okay, but that 120, let's take a look at what this is including. Okay, that 120, if I redraw this, right, C, A, B. I'm going to draw that first. So that's 60. And then I'm going to draw this a little weird here. I'm going to redraw AB, right? I'm just going to kind of draw them side by side. A, B, D. That's also 60. So now notice we have AB appearing here twice. So this 120 here has AB appearing twice. The 98 has AB only appearing once. So if we subtract 98 from 120, we get 22, and we can conclude that the length of AB is 22 units. Okay, on this page we'll look at number 7 and number 9. So number 7 says that AB is 2x squared, BC is 2x, and that the whole thing is 24. The question is B the midpoint of AC? So we can use segment addition to set up an equation. And there are other ways to do this we talked about in class, but the most direct way to prove whether B is the midpoint or not is to set up an equation using segment addition. Now notice this is a quadratic, right? This x squared here is going to indicate to us that it's a quadratic. So we want to subtract 24 to set it equal to 0. And now we're going to have to factor. Now notice we have a common factor of 2 here that we can pull out and make our life easier. And if we find the two things that multiply to negative 12 and add to 1, that is a positive 4 and a negative 3. So x is either negative 4 or positive 3. Now note that x can't be negative 4, because if we plug negative 4 in over here, we would get negative 8 for the length of BC, which is not possible. So x must be 3. So if we plug x equals 3 in for the length of AB, 3 squared is 9, times 2 is 18, and then 2 times 3 is 6, and so B is not the midpoint, because those two segments are not of equal length. And finally, number 9, B is the midpoint of AC, and CD is 8 less than twice AB. AD equals 64. Find AC. So we know this whole thing is 64. We also know that B is the midpoint of AC, so that makes AB and BC congruent. And then CD is 8 less than twice AB. Okay, and AB is x. So twice AB, 2x, minus 8 is going to give us CD. We want to find the length of AC. Okay, well, since we know that AB and BC are congruent, we can do a couple things. We can say that, well, x equals y plus 5, and we can set up a system of equations, or we can simply just call BC x, because they're the same. And then we could take all of these little segments and add them all together. X plus 2x minus 8, that all equals 64. So that gives us 4x minus 8 equals 64. 4x equals 72. And x is 18. So the question asks us to find AC. Well, AC is this segment here. And if x is 18 and there's two of them, AC must be 36.